Question is to Sri Prakash College, helping him in terms of MOOCs and how successfully it has been received not only at the state government level, but also at the central government level. So that is the goal. With that, we kind of finish all the units, and you will be ready for your midterm or internal exam, as they call it. If time permits, I just wanted to do a quick review of some additional data structures. In particular, I wanted to talk about linked lists and how do we implement a stack, for example, using a linked list or an array. It should be like a refresher for you because these things should have been covered in your second semester or first semester data structures class. But I do not know who taught you and how long ago it was and whether you remember. So I'll do a quick refresher and then tie that to the complexity analysis. Like, for example, if you implement a stack using an array, what would be the big O? And if you implement that using a linked list, what would be the big O? What are some advantages and disadvantages of implementing a stack as an array versus implementing a stack as a linked list? Just a couple of quick refreshers like that before the break for internal exam. That's what I mean. Okay. So let's jump into job sequencing example. Okay. So what is job sequencing? So we have n jobs. Okay. J1 to Jn, as it says here. These jobs are, think of them as programs or processes that need to be executed on a machine. And then they have a deadline. Okay. Now, if you execute the job, there's a profit involved. Okay. So, three distinct concepts: jobs, deadlines, and profit. Good morning, Aditya, College of Engineering. Hope you are able to hear me. So if you hear me, all of you, I mean, some of the college, and of course, the objective is important, right? Okay. Get ready with your papers and pencils and all that stuff, and faculty members on your feet, walking around the class and making sure all of them do it. Okay. So here is a small example. We have 5 jobs. J4, J5, that's row 2, right? And each of them have a deadline. Okay? 2, 1, 3, 2, 1. What is the deadline? Meaning by second unit of time, they should be done. If it is 2. Okay? And then the other one is 1. By deadline, 3 units of time, the job would be done. Remember, the other assumption we made was all jobs take 1 unit of time to execute. Okay? In reality, that's not true, right? They take multiple units of time. Now, when you execute the corresponding job, you earn a profit of 60. Profit could be, 60 is any unit, right? It could be dollars, it could be something else. Okay? So that's the example. And we have to figure out how to do the job sequencing for these 5 tasks so as to maximize the profit. Okay. So what do we do in that case? We sort the jobs. This is how job sequencing works. I'm giving you a working example, okay? Excuse me. Sort the jobs according to their profit in descending order. Okay, so when you sort the jobs, what do you get here? Remember, it's a collective exercise. So job 2 has maximum profit 100. Okay, so you put that job 2, it's a descending order, right? After that, J1 comes. After that, J4 comes. After that, J3 or J5, because they both have the same profit, you can choose one of them. Okay, so that is the descending order. Okay. Then, after we do that, we find the maximum deadline value. Okay. So if you look at the maximum deadline value, the previous thing here, if you look at the deadline row, see the maximum deadline value is 3. That's important for us because by the time 3 units of time is over, after that, this sequencing is useless because we have 3 units of time. So you have to keep track of up to 3 units of time, right? So if you see time slot 1, time slot 2, time slot 3, okay, because maximum is Dmax is 3. If that showed 5, then you would have created 5 columns here. Time slot 1, 2, 3, 4, and 5. Okay. So you initialize all those time slots to empty. Okay. Now, continuing that example, for the sake of clarity, I put that index and the jobs up there in the descending order, if you see, J2, J1, J4, J3, and J5. So we have 5 jobs. The number of time slots are only 3. That's the second bullet. Okay. So there's some explanation I gave, right? If you look at job 2, it has a deadline 1. This means we have to complete job J2 in time slot 1 if you want to earn its profit. Okay. Similarly, if you look at other jobs, they have their deadlines. Okay. So jobs out of those 5, because we only have 3 time slots. And the way we select them is we want to get the maximum amount of profit. Everyone understands that? So we have jobs listed. We have put them in descending order of profit. Okay. We have seen how many times, and then we have looked at the maximum deadline. We created that many time slots. We initially look at the big table, and then we have to select, because the number of time slots is 3, we have to maximize our profit. That is the objective function. So how do we do that? Here is some kind of a pseudocode for that. Okay. I'm giving you the pseudocode. Okay. For I equal to 1 to n. What is n? N is the number of jobs. Set k equal to some min Dmax deadline of the job I. I'm not explaining what that is. I'm just showing you. And then you have some kind of a y. So what is the, and here is some C code for that, by the way. Okay? There's a bunch of C code here. Okay? I'm just hitting return. Okay? Where did the table be? Okay. So when you have when you go back here, this is the table. Write down on a piece of paper. Okay. Time slot, status, and tell me which of the 3 jobs you would select, right? That's number 1. Okay, fill the table. Okay, only thing is I want you to fill the table while tracing the code. Okay, not simply look. Visually, you can fill the table. Okay, here is one thing that you can do. Visually, without tracing the code, you can fill the table to begin with. Okay. From this one, visually you can fill the table. Which one you can select, right? That's number 1. After you do that, I want code. Okay, you all know C code, right? This is the algorithm, by the way. I want you to understand what this algorithm is doing, but this is exactly what is actually implemented in C code here, okay, with all the bells and whistles. Okay. Okay, so what I want you to do is go to the code. What is the code? You will say, oh my God, code is a bunch of slides here, right? Okay. Trace the code, fill the table, write down the Dmax value based on the code, not on whatever the tracing of the code is, okay? And show the required jobs. Show the sequence in which the jobs are executed. And what is the profit outcome? Okay, what is the maximum profit? Does understand what is to be done next? Is there anyone who doesn't understand? Type no in the chat. Then I'll try to explain it in a different way. Now, where do you see the? Let me go to com, or I'll show the Word document. Give me a second. File open. Okay, yeah, let me share. Good morning, PVP Siddhartha. We are doing the job sequencing thing. Okay. If possible, please explain again. Sure, will do. Okay, give me a second. So we have what we covered so far is job sequencing, right? So when you have a job sequencing, what are the things that we have? We have given a list of jobs. No problem, Siddhartha, I'll explain. Okay. The third data point is, what was the third data point? A blank dot in. Maximize the profit. That was the third data point. So we are given some kind of a see, these are the jobs. We are given jobs. Okay, J1, J2, J4, J5. Each job has to be executed by some time slot. By time slot 2, if you take a reference point now, in 2 times, and each you should execute this job, J1. I'm looking at index 1, J1, 2. If you go to index 2, J2 has to be executed by end of first time slot. If you go to job 3, that has to be executed by end of 3 time slots. Okay. But depending on which of these things are executed, you can see if you complete the action, you will get the profit of 60, 100, 20, 40, 20. Okay. The goal is to maximize the profit, meaning you have 3 time slots. You have 5 jobs. Which of those 5 jobs you would execute in those 3 time slots? Because the assumption we are making is every job takes 1 unit of time to execute. For simplicity, I assume that they all take only 1 unit, okay? But in reality, that is not true, right? If I have to give you a real example, see, I run a consulting company. Okay, let's say a client comes and says, "Hey, I want you to write a quick program for me to automate this small task." Okay, fixed cost project. Okay, we'll say, "Hey, I'll give you 20K, fixed cost project." Okay, now, and I have 3 programmers sitting on the bench. Those are my resources, right? Job scheduling is managing resources too. Okay. Which of those 3 programmers would I choose on that project? Basically, I'm scheduling one of those 3 guys to finish that project, right? Who would I choose? Who can answer that question? Is the question clear? I just got a client project for 20K. Okay, and I have 3 programmers sitting on the bench. Now I had to select one of those resources to execute the project. Okay. Which of them would I choose to maximize my profit? Faculty members are welcome to answer that. All of these things fall under the same category of job sequencing / resource scheduling and things like that. It's a no-brainer, right? If I have 3 programmers, Tom, Dick, and Harry, if Tom is a super sharp programmer, right, and then Dick is average programmer, and Harry is totally useless, he'll take forever to finish a project. So which of those guys I would choose? And it's a fixed cost project. I would choose Tom because he will finish it in 1 day or 2 days, right? And I made my money because it's a fixed cost project. The faster I finish, the more profit I have, right? Because then I can use Tom elsewhere, right? Now, the same situation, of course, if I change it slightly differently, I say the guy is paying for time and material, okay? I would probably money. If I choose the average programmer, he'll probably take 10 days and get me more money, right? The objective function is to get maximized profit. Of course, in real life, that's not how it works, right? In real life, quality matters too. Because it doesn't matter what the objective function is, I always give my client the best. Because the client is thinking, oh my God, this is going to take 10 days and going to cost me 20,000. And then I finish it in 2 days. And I get 4,000 because $2,000 per day. Then the client is happy that I saved him 18K. But the next time he thinks of a 100K project, he will think about us only. So that is how in real life. But here, going back to job scheduling, that's what we are doing here. We have jobs, we have deadlines, and we know what is the profit value. How do we sequence them? That is what the purpose of this class is today to discuss. So we said we'll sort the jobs according to their profit first. Okay, this is not sorted. 60 came first, 120. So when we sort it, you can see they're sorted by descending order of profits. Okay, there are 5 jobs. After we sort them, we find the maximum deadline value. What is the D max? 3. That's what it shows here, right? Where did I write the 3 there? I missed some example there. Yeah, here. So that means once we know 3, then what we do is we create these 3 time slots, because by then we have to be done. That is the maximum. Okay, those 5 jobs have to be executed. Worst case by Dmax equal to 3. Each slot is 1 slot, and we are assuming that every job takes 1 slot to finish execution. So we initialize the status of the 3 time slots. If Dmax was 5, I would have created time slot 1, 2, 3, 4, 5. Okay? Important concept there. Dmax, what is the maximum, right? How many time slots we have at our disposal. Okay. We initialize the values to empty, empty, empty. Okay, so now we have the picture here. We have 5 jobs. Dmax is the deadline. If you go back here, see this row 3 just before job deadline. So J2 in this case takes 1 time slot. By first time slot that should be done. Within 2 time slots, the second one should be done. If you continue like that, this 3 shows by 3 time slots that particular job should be done. J3 should be done. That is what Dmax is. Okay, deadline. What is the maximum deadline value that you have? D is for deadline. Okay. Okay, so we said we know the number of jobs, we know the time slots, we put 3 there, and if you look at job 2 as an example, it has a deadline 1. That means you have to complete job J2 in time slot 1 if you want to earn its profit. Okay. If job J1, if you look at job J1, it has 2 time slots, meaning we have to finish that job on or before time slot 2 in order to earn its profit. Correct. So Prakash, that's correct. This means all max deadline among all jobs. You got it. The deadline is 3. That means we can complete job 3 on or before time slot 3 in order to earn its profit. And what is our objective? We have 5 jobs. We know Dmax is 3. That means we have 3 available time slots. And our objective is to select the job that will give us the highest profit. Okay. Okay. With that, how do we execute that? So what is the algorithm? Visually, when I look at the table, what are the 3 jobs that I need to select? Can somebody tell me to maximize the profit? First, followed by why J1? Remember, all things take only 1 unit of time to execute. This deadline is only saying by 2 deadlines you should finish. Right? Each of these tasks would still take only 1 unit of time to do that. So let's look at some answers that people put here. Lima put, I think it's Lingaya Institute, I think, right? Management and Technology. They put J2 and J1. Lingaya put J2 and J1. Okay. So if you do J2, you get 100, and then you do in the second time unit, you do 60. We still have 1 more time slot. Remember the 3rd time slot. So if you stop at J2 and J1 and do nothing in the 3rd time slot, your profit would be only 160. The 2 is not 2 time slots. It doesn't take 2 time slots to execute. Every job takes 1 unit of time. Each time slot is 1 unit of time. Okay. Now, would you like to change the answer? All the deadline says is, hey, by the time of the second time slot, we should be second or third, whatever. If I say 3, by the end of 3 time slots, I should finish the job. Now you got it. Okay. C. Prakash got it. Okay. Did everyone else get it? So what is the right answer now to maximize the profit? Put it one more time because I got too many answers here. Obviously, you'll choose 3 jobs. Which 3 jobs you choose here is the question. Let's look at it. J2 is 100, J1 is 60, and J4. Because now you know why we have to sort it in maximum order of profit. You got it. And the total is what? 200. Okay. Now here is the problem. You have a small problem there. J2, fine, first time slot. J1, by end of second time slot, you should select done. But how can you select? You cannot select J3, right? You can, because it should be done by end of second time slot. We could not, so we will not select that. Then you choose J4 or J3 rather. Sorry, yeah, not J4, J3. You cannot select J4 because that should have been completed by end of 2 time slots, right? So you cannot select J4. Vitam, you understand that? Because you are the one who gave that answer. J2, J1, J4. Because by end of 2 time slots, it's done. Since you did not do it by end of 2 time slots, you cannot select J4 because it's useless. So what is it that's available in the time slot by end of 3rd time slot? You can still execute J3, right? So the order would be J2, J1, J3. When I was yesterday when I was preparing this, remember I told you I always prepare for classes. Just because I know stuff doesn't mean I don't prepare. I still prepare, right? Because these are all requires deep analysis. Okay. When I was preparing, I was looking at it, even I got confused. I couldn't figure it out. I think maybe because I was tired or sick or whatever. I was looking at it, staring at it. Something was not connecting in my mind. Guess what I did? I just called up my son, who happens to be a Berkeley computer science graduate. So I just discussed it with him. I said, hey, I'm having difficulty understanding this. Simple one, right? But I discussed it with him for 5 minutes. And we took out a paper and a pencil. We started writing some example. And in 5-10 minutes, it got clear. Okay. What is missing here is what this table does not. Right? Let me see if I can write it somewhere here. I'll minimize it for a second, okay, because I want to use a text box. I want to go back to slide mode here. Give me a second. I screwed up something here. View. Yeah, better now. I will insert a text box. Okay. Each job takes 1 unit of time to execute. Everyone understands that? Okay. So, Sri Prakash, you put no there, right? Now, everyone else too, everyone can answer this. Each job takes 1 unit of time to execute. As that job gets the access to CPU, and then that one clock cycle of CPU that gets executed. Okay, we call it 1 unit of time. That's an important concept, okay? That's number 1. What does deadline mean? That is the next concept, right? Okay. So I'll draw time slots here, okay? So if I say insert table, okay, I'll draw 2 here, okay? So I'm writing here, I hope you can see that, time slot, I'll call it time slot 1. We had a lot of fun yesterday when we were doing this. And my daughter comes in between and tells me, Papa, how come you're teaching and you don't know it? And I call my son. So we have all those kinds of engaging discussions in the family. And to tell her, professors don't have to know everything, you know. They can forget too. Okay, that is time slot. Sorry, 2. Okay, time slot 3. I'll write one more, okay? Time slot 4 and so on, okay? These are units of time, okay? So every unit of time you can execute one job because we only have one machine. That's another assumption. Everyone understands that? Okay? So you can execute some job here. You can execute some job here. You can execute this some job here. And you can execute this job here. You got it? That is the time slot concept. Is there anyone who does not understand that? Say no in the chat, and I'll explain. Okay? Now, each of these jobs, they say, what does this deadline mean? Deadline means, hey, this, if you take J2 job here, right? It says, hey, you have to finish executing this job in time slot 1. Okay? That means if I say J2, the only place where it can execute is where? Slot 1. What other job? End of time slot 1 in the table. Which other job? Let's put that. Shouldn't take more than 2 seconds for you to answer that. In time slot 1, by time of time slot 1, J2, J5. Okay. Now, what are the jobs that need to be executed before, on or before time slot 2 from the table? Easy, right? J1, J4. Correct? You can see my screen, or is it too small? You want me to increase the font size? I can do that. Better? Got it? Okay. You agree? J2 and J4. What job you can execute on or before time slot deadline 3, meaning time slot 3? J3, correct? Agree? Correct? Now, what is our objective thing here? We want to maximize profit, right? Now, that means in each time slot, I should execute something which gives me bigger bang for the buck, as they say in US, right? Okay. So, if I still take the same unit of time to work on these jobs, would I choose something which pays me more, or would I choose something which pays me less in real life? If I'm working for 1 hour, if one job pays me $100, and if I work the same hour in another job which pays me $20, which one would I choose? I would choose the $100 one, right? Because I get more returns. Okay. Unless you're Anna Hazare, he will say, I'll choose something which has zero money. Okay? I am not a zero money guy. Okay? Profit. It's all about profit. So which one would you choose between J2 and J5 now in time slot 1? You would choose only J2, right? Correct? Which one would you choose in time slot 2 between J1 and J4? J1 says 60, J4 says 40. So I will choose J1. Which one can I choose in time slot 3? J3, because that was only one. Okay. Now what are the values? If you put one more thing, J2 is value is profit is 100. J1 value is 60, correct? So that's 160. And J3 is 20. I get 180. Do you see the light at the end of the tunnel now? Is there anyone who does not understand that still? Okay. I see the madam happy there in Sri Prakash. Now I can move on. Okay. ఇక్కడంతా తీసేయచ్చా ఇది? Okay, good, excellent. So Adi, to find those things, there's some algorithm here. Okay, it's easy to explain, right? Now, how do you take all that explanation and put it into a pseudo code? So I have some kind of a pseudo code here. Okay, for that to solve that problem. Okay, now pseudo code is no good. When you are a programmer, you should know how to program it too. Okay. So I have a whole bunch of C code there, copy pasted it from different sources. Okay, I don't need to reinvent this stuff. So this is the C code for that, runs into several pages, hard to read the code. Okay, I'll tell you how you are going to read the code shortly. Okay, the intent of this is I want you to see how I started filling the table visually, right? Similar thing. You start filling a table like that while tracing the code, the C code. And from the C code sample, you can figure out what the Dmax is. Okay. And then show the sequence in which the jobs are executed. And then tell me the profit, resulting profit. What I showed you visually for the last 5-10 minutes is what you will do using the code sample. So let's look at the code sample. Let me share my, am I sharing the Word document? Can you see my Word document here? Just type yes if you see my Word document, please. Okay. So I'm assuming that you can see it. Yes. Okay. Thank you. For some reason, why I'm not able to scroll through my Word. Faculty members, print out this code because I gave different values are J1, J2, J3, J4, J5 ani. But what I want the students to do, you can change the values. Okay. Please feel free to each group for the fun of it. Jobs file change these values. Okay. Don't copy simply the values that I gave there, 60, 100, 20, 40, 20. Okay. You are welcome to change values if you want to, optionally. Okay. Change the deadlines if you want. Okay. These are the creative things that you can do. Follow the, when you trace it, when you say job temp, you're so trace what this loop is doing. Okay. That is the descending order that I talked about. But I want you to physically trace it. So that way you get a feel for it. Just don't say, oh, what is this for loop doing? Look at the comment. I could have removed the comment, right? But I kept it there. But I want you to trace it, how the for loop is flowing, what exactly J is doing. Okay, what is N, right? And then there's a printf. So what is it printing on a piece of paper? you put something called on the top output. So if this is the first printf statement, what is it printing here? Is this creating some kind of a table, or how does it look, that output? Okay, print that output. Okay, so like that you trace this code. Okay, everyone understands that? Now the code is, let me share my screen again. I'm going to share now. I'll share it for a okay, that is the exercise. Fair enough. Now it's 10:13 p.m. here. That is 10. Dmax you would know from there. The sequence of the jobs you should figure out from the trace. And then what is the profit? At 12 o'clock, after you're done with that, yeah, this is all the piece of code. Okay. After we are done with that, then in the remaining time, we'll get into, as I told you, some linked lists and stacks. Okay. I should put it on this slide. Okay. Okay. I'll go on. Stories about Nainatara when I was muted. You missed all that good stuff. Just joking. So what I was saying was, I told you earlier that at some point I will do a quick review of additional data structures. Correct? So we said that if you write a great algorithm but you use a poor data structure, your algorithm is no good. You're only so choosing the right data structure is important too. Okay? So you can implement it. You can implement a certain algorithm using arrays, lists, right? And then abstract concepts like stacks, queues, heaps, all kinds of things, right? So the intent here for the next few minutes is to do a quick review of a couple of data structures. And then next week when we meet again, I will review a few more and things like that. And you got something like this. This algorithm is to sort the n jobs. Remember, we sorted them, right, in decreasing order of descending order of profitability. We know from sorting algorithms unit that sort algorithm is big O of n log n. Okay. Then we had to take each job and start where the deadline is given, and then you keep searching for the vacant location. That's what your code was doing. So if there are n jobs, and for every job we need to search n slots. Remember, as n tends to infinity, even though you fill some, you still call it n, right? So it's n times n, that is n squared. So the totality of this would be complexity is n log n plus n squared. Now we also know the simplification rule where we drop off the lower order terms. That's why it's called asymptotic analysis, correct? We are dropping off, filtering out the lower order terms. Compared to n squared, n log n grows slowly, so we drop off n log n. As a result, the algorithm complexity is order of n squared. Okay. It is possible in an internal exam to give you simple examples of code and ask you to tell what the big O is. Unfair to ask what is theta. Okay. Okay, here is a quick review of additional data structures. I first thought of asking you as an exercise to do this, what this code does, but I'm skipping it for now in the interest of time. But you can convince yourself about this small code. Okay. But if you look at the top left corner, this should tell you something what this struct list underscore ELS. This is how you define a list structure, because a list has a link. I mean, what do you call it? Singly linked list, right? A list has a value and a pointer to the next. That's the structure in case you've forgotten how to declare a linked list node. Okay. I'll let you convince yourself what the code does and what the output is. Okay. But that code basically shows you how to use a linked list as opposed to an array, right? The advantage of linked lists are nothing but they are equal to the disadvantage of arrays, in case you forgot from your second year class. Okay, so array size is a limiting factor, right? Once you declare an array of fixed size, you cannot add any more elements to it. Okay, so when you are doing industrial strength applications, the chances of declaring static arrays are far and few in between. I mean, we still declare arrays. It's not like we don't, but far and few in between. And then again, memory allocation, right? So that's a big advantage of linked list, because you allocate memory as and when needed. As your list keeps growing, you add more memory. So use it only when you need it. Whereas in the case of array, whether you use the full array or not, you still have to declare the full thing. That means memory has been allocated to it. Insertion and deletion is much easier in lists as opposed to arrays. What happens when you have to insert an element? Let's say it is a sorted array. When you want to insert an element, still maintain the sort. Potentially, you have to move rest of the elements in the array to make room for the new element, right? Otherwise, you'll have a problem. Same thing with deletion. If you're deleting, you have to coalesce the remaining elements. So those are all big disadvantages of arrays, as you may have learned in your second year class, which the list solves. Linked list. When I say list, linked list. Okay. Insertion. Okay. So you can insert an element at top of the list, or at the end of the list, or you can insert in the middle of the list, right? There are three main concepts associated with lists. So how do you insert in the list? Top means the head pointer should be pointing to that, right? So you first create a node, you assign the data values to the node, and then you have to connect the pointers, right? You have the head pointer, and then you have, of course, tail pointer and things like that, right? So here is some pictorial representation of a list. Yeah, as you can, it's pretty self-explanatory. Okay, head pointing to the first element of the linked list, and the last element of linked list would be pointing to null. Okay, so step number one, what do? We create a node, right? That's what it says, and then set the node data values. So step number one, you can see you created the node. In step number two, you inserted the value. Once you insert the value, you need to connect that. Okay, so that means the head should be pointing to 93, and that 93's pointer should be pointing to 48 now. So the head has moved now. That's how you insert. Okay, here is a pictorial representation of a singly linked list again. Now, as opposed to singly linked list, you can also have doubly linked lists, right? So you have the element and you have the concepts called previous pointer and the next pointer. That's how you connect the nodes in a doubly linked list. Okay. Now, other important concept that you may remember or may not is the concept of stack, right? So what comes to mind when you talk about stack? Three things: push, pop, and where is the top of the stack? Because whenever you're trying to insert an element into the stack, you need to know where the top is. Okay, so these are the three elements. By the way, I'm going fast because I assume that you learned all this in your second year data structures class. If you guys need me to, be happy to do that next class, okay? We have plenty of time. And if you want to know where I get all these slides, if you go to the community and look up my data structures class, the second year one, you will see all of these things posted there. So this shows you some graphical representation of how a push operation works, right? So we're trying to push data that has to go to the top of the stack as it is shown on the right here, okay? By keeping track of top, you know where to put it, okay? Now, is top pointing to an empty slot or is top pointing to the one which is there on the stack? Based on this picture, where is top pointing all the time? It's certainly not pointing to the next available slot. It is pointing to the slot where the top element is. If you're popping wherever top is pointing to, and then you decrement the top pointer. That's how a stack works, right? So I gave you an example of a stack where you're pushing and popping and all that stuff. Convince yourself with this graphic as to how a stack works. Somebody asked a question. Computing from this data structure. You're talking about stack, right? Plenty of examples, right? If you take, for example, did you do like what in your class? Did you talk about arithmetic expression evaluation? Right? Real-time application, right? Whenever you have to implement, do arithmetic expression evaluation, you have to use stack. By the way, C. Prakash, you can always put your chat in for everyone, so that way they get the benefit of your questions too. Okay? Questions. Okay, what is other real-time example of stack? One is arithmetic expression. The other one, in terms of where we use stack significantly, is in program calling, right? The entire compiler technology is built on the concept of stack. The program call stack that you have when you're computing, when you are executing code, how does the code know to go from the main to some procedure P1 and come back to the main the next line? The entire compilation and that execution, the runtime execution stack is maintained by the system while it is executing a program. That's another real-time, real-world example of a stack. I go into very gory details of these things in that second year, first semester class. So I have tons and tons of slides. I just chose a few just to warm you up a little bit here. Okay. So now when you have a stack like that, right, we have, now, is there in the syntax of C something called a stack? No, right? We don't have a construct called stack. We have constructs called like structs, integer, character, and things like that. And we have array, concept of an array. But we do not have a concept of a stack. That's why it is in one sense an abstract data type. Abstract means we use that concept to understand the problem that we are trying to solve. That's what an abstract data type is, right? It's a modeling concept. It is not an implementation concept. That means a language does not have in the syntax something called stack. So once we design these things, then we have to implement them. We can only implement them using the structures that are available to you in that programming language. Okay? So there are a couple of ways of implementing the stack. Okay, stack is nothing but a list of items, right? Now, can you implement a stack using array? Because array and all the stack elements typically are of the same element type. So what is the construct that's available to us which we can use to implement the stack readily, which has the same notion as all elements are of the same type? Array, right? So you can implement a stack using an array. Okay. Now, what did we say about linked lists? We said, hey, linked lists are a better mechanism than array because they address the disadvantages of array. Okay. So all of a sudden now, as a programmer, you have two choices as to how to implement a stack: choosing between an array versus choosing between a linked list. It will help you determine what to choose. Criteria that would help us determine whether to implement stack as a array or whether to implement stack as a list based on criteria to decide which one we would use. Anyone can answer that, including faculty members. Do you think performance is a good criteria? If we are using a linked list, and if it performs better based on what we know about linked list versus array, muted myself again. So here is a pictorial representation of a stack, right? He's showing you how a stack is. The stack has count and the top of the stack. That's the concept. And then each node in the stack node data structure, it should have a data and the link, because we are talking about a linked list implementation, right? That's why we have a link. So each element, remember, stack is a concept, but when you're putting it in programming language syntax, you're using a linked list. So top of the stack means is always head, right? Possibly. Yeah. Bottom of the stack is the tail. That is the concept here. So when you go to these slides, you can see how it is built. If you take the first one on the top, you see before picture, after picture. Before there was no stack. Once you create a stack, you'll see one node there which has no values. That is the bottom. Now you're adding one node to that in the second one, push stack. That means when you push, you're pushing one element. Okay? So that green, you can see that green data and so on. So green is the first element, second element, and things like that. Then pop. So there is a pictorial representation of how it works that you can convince yourself. And then I gave you the algorithm to create a stack. How do you create it? It's a beautiful piece of code here. If you notice something here, this is how we write the code and specs when you're working in Silicon Valley, okay, with a good team. You see the pre-condition? Pre means nothing exists. Post-condition, what is the outcome? The structure is created and initialized. And what is the return value? It's a stack head. Okay, so the algorithm is you have to get the node. How do you get the node? You allocate memory. That's how linked list grows, right? Remember memory allocation algorithm, right? So you allocate memory, count to 0 because there is nothing has been pushed yet. Top is null because there is nothing got pushed. Remember, top always points to the element that is on the stack. Right now it is null. Okay, so you're returning the stack head. Okay, so this gives you pushing onto the stack example here. You're pushing a whole bunch of values. You'll see the before picture, after picture. Okay. So here is the algorithm for push. What happens when you push? Okay. Pre-condition, post-condition, and what are the steps that you take? Again, I'll not go through each of the steps. I want you to trace a piece of code to see how this algorithm works as kind of informal homework. Okay. Same thing, I gave you a visualization of pop. And that's a piece of algorithm for pop. Okay. Now you have to keep track of stack top. So what happens? How do you keep track of stack top? Again, piece of algorithm for that. Here is empty stack. How do you determine or not? And then here is a different full stack. Okay. How many elements are there in the stack? Different pieces of code. And then ultimately, whenever you allocate memory, good programming principles say that you should deallocate memory. And that means you're destroying the stack here. Okay. Now, look up some C code. I don't know if I gave you C code here or not. Let me check. Okay. But when you do these things, ultimately you have to undo the time complexities, right? You are a tech lead. You're working, and your junior programmer came there and implemented a stack based on array thing or based on lists. Okay. So you have to do the analysis, right? When you're doing the analysis, you have to do the insert operation, right? That is, you're inserting into the stack, right? You can see the complexity there, and in the worst case, because you're adding to the, if you're adding to the first location, all n elements of the array have to be shifted one place to the right. Okay, if you're adding to the first one, so potentially on. Turns out, if you're inserting in the full list, it's also on. Okay, whether you're using array or whether you're using list, you'll get the same on there. So I gave you some values for all of these things. Take some small examples and convince yourself these are true. All you have to do is take, let's say, 5 elements, okay, or 4 elements. And then you can do a quick analysis and extrapolate that, right, to n. Okay. Remove operation on in the worst case, right? Because if you remove it from the first location, you have to remember I told you array problem, you have to shift all the elements. Okay. But retrieve, replace, and swap are order of 1 because it's array. Array has random access, right? Okay. Find is on again because it's array. Now you can see here singly linked list with n nodes, adding the head, remove head, all of them are O1. Right? Reference, meaning you're keeping track of it. Otherwise, you have to go through the entire list. Okay? Got it? Something like that. What else I gave you here? Okay. Same story here. The movie is same, right? And I gave you some time complexities for doubly linked lists as well and ordered lists, right? So these are the kind of things that you would be analyzing as computer scientists to distinguish between the various algorithms given by your team members, right? Guys who have a good understanding of data structures and the time complexities would typically come up with good code like this. Okay. Okay, I'll stop here. I have a couple of other things which I want you to just review in case you forgot. And if I gave you code here, putting the code in the slide deck, I'll post it in the community. Okay. Okay. Somebody said clarification from NACSA theory of these things like lemmas and theorems. Number one, they're totally, I'm not sure if it is relevant in a time complexity and things like that. From a practical viewpoint, those are great for academicians, okay? Because remember when we introduced the concept of a tree and a graph and all that, there are a bunch of lemmas and theorems associated with all kinds of properties related to trees and all that. What good is that from a practical working knowledge perspective? You give me one good reason as to why I should discuss that, I'll be very happy to discuss that. Right? In my opinion, they are best left to the students to go look up some theory unless you come and tell me, no, in the final exam we will, but those are not lemmas. Profit rate should be descending order. Yeah, I can tell you those kinds of things, why they are in descending order by giving an example, right? So it's similar to what you're saying about profit to weight ratio, right? In essence, that right. We get the profit to weight ratio even in the to give working